Consider the following quadratic function. Y equals negative 3x squared plus 24x minus 45. Step 1 of 5. Rewrite the given quadratic function in the form y equals a times x minus h, that quantity squared, plus k. Reduce all fractions to lowest terms. Once again, we're going to have to complete the square. Y equals negative 3x squared plus 24x minus 45. We'll start by moving our constant term by adding 45 to both sides. Y plus 45 equals negative 3x squared plus 24x. Remember, we will like our leading coefficient. When we're completing the square, it needs to be 1. So I am going to factor out a negative 3 on the right-hand side, which is going to leave me with x squared minus 8x. I'm leaving a space there. When we complete the square, we take 1/2 times negative 8, which is negative 4. Negative 4 squared is 16. So here it's going to be plus 16. But what I add to the other side is going to have to be negative 3 times 16, because I would distribute that negative 3. Negative 3 times 16 is negative 48. So y plus 45 minus 48 equals negative 3 times x minus 4, that quantity squared. Here we're really adding the negative 48 as well. 45 minus 48 is y minus 3 equals negative 3 times x minus 4, that quantity squared. So I'm going to add 3 to both sides. Y equals negative 3 times x minus 4, that quantity squared, plus 3, which is what's going to go right here in this box. Negative 3 times x minus 4, the quantity squared, plus 3. Step 2 of 5, find the vertex of this function. I copied over the vertex form. Our vertex is 4, 3. Step 3, find the x-intercepts, if any, of this function. Express your answer as ordered pairs. And once again, I think I can factor this. So that's what I'm going to try to do. I'm going to start with this form, y equals negative 3x squared plus 24x minus 45. And I am going to set that equal to 0 because I'm looking for my x-intercepts. And then I'm going to divide everything by a negative 3, which leaves me 0 equals x squared minus 8x. This is a minus sign. So negative divided by negative, so that's plus 15. Which this factors into x minus 5 and x minus 3, which means I have 2 x-intercepts, and they are 5 and 3. So 5, 0, and 3, 0. Step 4, find the y-intercept. Express your answer as an ordered pair. Remember, when it's in standard form, we're plugged x equals 0 in, and so it's our constant term. So 0, negative 45. Step 5 of 5, graph the quadratic function. We have our vertex at 4, 3, our x-intercepts at 3, 0, and 5, 0, and our y-intercept at 0, negative 45. Once again, not going to be able to graph that, but we can graph the others. So our vertex is right here at 4, 3. I have a y-intercept at 5, 0, and a y-intercept at 3, 0. This is our function. It's opening down, which has got a negative a value. It's negative 3, which is greater than 1, which means it's skinnier.